All right, guys, we're on day 1, and this is entitled sequences. A sequence is defined as a function that has its domain as the set of positive integers. Okay. The number of the term, so for instance, the first term, the second term, the third term, okay, is the input into the function. These input values cannot be negative or 0. For instance, we don't have a 0th term or a negative first term. And so that's why they say that our domain is the set of positive integers. Okay, so our domain will be 1, 2, 3, ... Okay. The actual term of the sequence, so whatever the first term is the output of the function. These output values can be any real number, including decimals, fractions, positive numbers, negative numbers, and 0. Okay, so for instance, what they call the first term, they actually call it a sub 1. All right, and let's say our first term is 7. A sub 2 is the second term, and let's say it's 14. A sub 3 would be your third term, and let's say it's 21. Okay, so 7, 14, 21, that's your range. Okay, those are your outputs. Okay, whereas the 1, 2, and 3, those are the inputs. Okay, and you can see that when you put an output with an input, it makes an ordered pair. So for instance, 1, 7, 2, 14, 3, 21. Okay, and so we can also use our table in our calculator to sometimes help us out and find things as well in sequences. All right, there are 2 types of sequences. There's what they call arithmetic and geometric. Okay, arithmetic sequences have an adding pattern, whereas geometric sequences have a multiplying pattern. Okay. Let's say, for instance, our adding pattern, let's say we start with 3 and we keep adding 4. So if we add 4, we would get 7. If we add 4, we would get 11. If we add 4, we would get 15, and so on. So that would be arithmetic. Whereas if we started with 3 and we multiplied by 4, we would get 12. If we multiplied by 4, we would get 48. And so on and so on. All right, so you're going to see that geometric grow faster. And because they grow faster, they are exponential. Okay. They call the multiplier an R value. Okay. And it's also known as a common ratio. Okay. Also known as your base, your multiplier. All right, so things that we've already just talked about in Unit 5 and somewhat in Unit 6. Okay? They're exponential functions. Okay? They have the form y equals ab to the x. Whereas our adding patterns, okay, because they go up with a consistent number that you either add or subtract there. Technically, you'll always add, but you could be adding a negative number. Okay? They call that a common difference, the number you're adding. Okay, they represent that with the lowercase d. And this common difference represents basically the slope. Okay? When you keep adding like that, you have a linear function, which has the form y equals mx plus b. Okay, so 2 equations we are super familiar with. We just have to realize that linears are modeled, or arithmetic sequences are modeled with linear functions, and that geometric are modeled with exponential. That they grow faster because of the multiplier, okay? Whereas arithmetics are linear, they have a constant increase or decrease. Okay. So in number 1, they're going to ask us for each of the following: determine the type of sequence and identify the common difference or the common ratio, depending on what kind of sequence we have. Okay. So they can look at the first one. To get from 5 to 10, we could either multiply by 2 or we can add 5. Okay. However, to get from 10 to 15, you're going to see that it's not multiplying by 2 because then that should have given us 20. So I believe we are adding by 5, and because we are adding, A for arithmetic. That makes it easy to remember. And because it's arithmetic, it's going to have a D equals 5. Okay. All right, in part B, to get from 10 to negative 30, we can either multiply by negative 3, or we can add negative 40, right? 10 plus a negative 40 would give us negative 30. Okay? To get from negative 30 to 90, if we add a negative 40, that should have been a negative 70, so it's not that. But our multiplying by negative 3 works, right? Negative 30 times negative 3 would be positive 90. And so we figured it out, and since we're multiplying, this is geometric. And geometrics have an R value called a common ratio, and your ratio is what you're multiplying by, which is negative 3. Okay. In my next one, 64 to 32, I could add a negative 32 to 64, and that would bring me to 32. Or I can multiply by a half. All right, so now 32 to 16. Well, the adding of the negative 32 wouldn't work there, but multiplying 32 by a half would give you 16. And since this is multiplying, this is geometric. Geometrics have an R value called a common ratio, and that's the number we're multiplying by, which is a half. Okay, so some people might say, hey, I'm dividing by 2, but geometrics and you have to multiply, so you have to think about what you have to multiply by. All right, so 1 over 2 instead of dividing by 2. All right, part D. 1 to 4. I could add 3. Can you multiply? Well, you can multiply something. What if I multiply by 4? 1 times 4 is 4. All right, so I'm either adding 3 or multiplying by 4. To get from 4 to 9, I would have to add 5, not 3. And 4 times 4 would have been 16. So this is what we call a neither. Not every sequence is arithmetic or geometric. Okay, some sequences, like this one, there is a pattern. It's just not that you're adding the same number all the way through and you're not multiplying the same number all the way through. And so they don't classify this sequence as arithmetic or geometric. All right, next one up. 4 to negative 1. I could say that I am adding a negative 5. Or I can say that I am multiplying by a negative 1/4. If you multiply 4 by negative 1/4, you would get negative 1. So if I look at how do I get here, negative 1 plus a negative 5 would get me a negative 6. This won't work. All right, and so I think we figured out that we're adding negative 5 all the way through. That will work. And because we're adding, this is arithmetic. Arithmetic have a common difference or a D value, which is what you're adding, which is negative 5. Okay, and the last one, negative 9 to 3. I could say that I am adding 12, or I could say that I'm multiplying by negative 1/3, right? Negative times a negative would be positive, and 1/3 of 9 is 3, okay? To get from 3 to negative 1, then well, that's not adding 12. But that would work if I multiply 3 by negative 1/3 to get negative 1. And so because I'm multiplying this as geometric, geometrics have a common ratio or an R value, and that's what you're multiplying by, which is negative 1/3. Okay. So hopefully you get the feel for those. So number 2 says consider the sequence 4, 8, 16, 32, 64. They want to know, is the sequence arithmetic or geometric? And so we'll go ahead and figure out, just like we did up above. To get from 4 to 8, we have 2 options. We can either add 4 or we can multiply by 2. So if we take a look at 8 to 16, 8 plus 4 would have been 12, so that's not it. But multiplying by 2 works. And so we're going to go ahead and say that this is geometric because there is a common ratio or number that each term is multiplied by. Okay. All right, so they want us to find a sub 3. Well, a sub 3, what that means is that they're asking for the third term. And we already know the third term because the third term is up here. It's 16. So we can say a sub 3 equals 16. Then they want to know what term. So this is a little bit backwards. What term is 128? So right here is our 128. So if we count 1, 2, 3, 4, 5, 6. So n equals 6. Or we could say a sub n. A sub 6 equals 128. Doesn't matter. Okay. All right. That was not bad. Number 3. Given a sub 1 equals 5, and the common difference is 3. So this time they didn't give us the sequence, but they told us what to do to create the sequence. We just have to remember that a common difference is from an arithmetic, and arithmetic is adding. So we're going to be adding 3 to get from term to term to term. So they gave us the first term, and it says find the first 4 terms. So we only have 3 more to find. So a sub 1 is 5. A sub 2, if you add 3 to 5, you get 8. A sub 3, if you add 3 to 8, you get 11. And then the fourth term, or a sub 4, would be 14. Okay. Part B says, is there a faster way to get to a sub 4 instead of listing all the terms out? Well, first off, it didn't really take us that long to get there, but they're trying to figure out, like what if they asked for a sub 20, like the 20th term? Now that would take a little bit more than writing out. So they're trying to ask us to figure this out so that if we do, all right, so if you remember what happened is that we added 3 here, then again we added 3, and then again we added 3. So they're saying if you add 3, add 3, add 3, okay, you're doing 3 times. So we're adding 3 times, which means that we're really adding 9 to the first term. And our first term was 5, and 5 plus 9 is 14, which was our fourth term. And so that is one way of thinking about it, okay? It says, in order to find a specific term or output in an arithmetic sequence, what are the 2 pieces of information needed? Well, you need to know the first term, which they call a sub 1, and you need to know what you're adding, which is the common difference. Okay. So now, notice they want us to find a sub 160. So that would be a lot of terms being written out. Whew. All right, so if we think about it, to get to the fourth term, we added 3 times to get to the fourth term. So it's 1 less because you don't have to add to get your first term because you already have it. So we would be adding 3 to get to 160. We'd be adding 3 159 times. And so 159 times 3 is 477. And now you have to remember that you're adding 477 to the first term, and our first term was 5. So 5 plus 477 would give us 160th term of 482. Okay. Cool thing is there's a formula that does this for us, so we don't have to keep thinking each time. We can write down the formula and just plug in. Okay, hopefully you remember formulas are shortcuts and they're not that bad as long as you remember to substitute in the right information. Remember that you have to have only one unknown that you're solving for. Okay. All right. I'll see you guys on the back side of notes.